Physical science students, we're currently on your last lesson for this chapter. We are on lesson 9.3, the behavior of waves. And our main idea is waves interact with matter and with each other. So we're starting off this section with the heading reflection. And please write down this slide. Reflection occurs when a wave strikes an object and bounces off of it. All types of waves, including sound, water, and light waves, can be reflected. How does the reflection of light allow you to see yourself in the mirror? It happens in 2 steps. First, light strikes your face and bounces off. Then, the light reflected off your face strikes the mirror and is reflected into your eyes. Next heading, echoes, and you'll want to write down the same thing here. A similar thing happens to sound waves when your footsteps echo. Sound waves form when your foot hits the floor and the waves travel through the air to both of your ears and other objects. Sometimes when the sound wave hits another object, they reflect off that object and come back to you. Your ears hear the sound again a few seconds after you first heard your footstep. On page 287 of your textbook, there's a lot more about the law of reflection in your textbook, and I want you to take a look at that on your own in the evening when you study. But for right now, please write down the things that are on the slide. According to the law of reflection, the angle of incidence is equal to the angle of reflection. That means all reflected waves obey this law. So the beam striking the mirror is called the incident beam. The beam that bounces off the mirror is called the reflected beam. The line drawn perpendicular to the surface of the mirror is called the normal. The angle formed by the incident beam and the normal is the angle of incidence. And the angle formed by the reflection beam and the normal is the angle of reflection. You'll need to record this slide. Refraction is the bending of a wave caused by a change in its speed as it moves from one medium to another. When a wave passes from one medium to another, such as when a light wave passes from air to water, it changes speed. If the wave is traveling at an angle when it passes from one medium to another, it changes direction or bends as it changes speed. So refraction of light in water. We're currently on page 288. Light waves travel slower in water than in air. This causes light waves to change direction when they move from water to air or air to water. When light waves travel from air to water, they slow down and bend towards the normal. So if this picture shows, if this is our normal, we have a flashlight and the light is coming in this way, we would think it's still supposed to go in this direction, but it doesn't because we've changed from the medium of air to the medium of water, which causes it to bend. And we have the same thing here in reverse. When light waves travels from water to air, they speed up and bend away from the normal. So here we have our normal, we have our medium of water, and our medium of air. I'm shining my light. It should go this way, but it doesn't, because when the light travels from the water to the air, it speeds up and bends away from the normal. Refraction of light in water. You may have noticed that objects that are underwater seem closer to the surface than they really are. In this figure, the light waves reflected from the swimmer's foot are refracted away from the normal and enter your eyes. However, your brain assumes that all light waves have traveled in a straight line. The light waves that enter your eyes seem to have come from a foot that was higher in the water. Copy the slide. Diffraction. When waves strike an object, several things can happen. First, the waves can bounce off or be reflected. Second, if the object is transparent, light waves can be refracted as they pass through it. And third, waves also can behave another way when they strike an object. The waves can bend around the object. So the definition of diffraction is this. It occurs when an object causes a wave to change direction and bend around it. Diffraction and refraction both cause wave to bend. The difference is that refraction occurs when waves pass through an object, while diffraction occurs when the wave passes around an object. Waves also can be diffracted when they pass through a narrow opening. After they pass through the opening, the waves are spread out. The amount of diffraction that occurs depends on how big the obstacle or opening is compared to the wavelength. So for an example, writing all of it down, when an obstacle is smaller than the wavelength, the waves bend around it. If the obstacle is larger than the wavelength, the waves do not diffract as much. In fact, if the obstacle is much larger than the wavelength, almost no diffraction occurs. So that brings me to hearing around corners. So you're walking down the hallway and you can hear sounds coming from the lunchroom before you reach the open lunchroom door. Why is it that you can hear the sound waves but not see the light waves while you're still in the hallway? Well, first bullet point, the wavelengths of sound waves are similar in size to a door opening. Sound waves diffract around the door and spread out down the hallway. Light waves, however, have a much shorter wavelength. They are not observably diffracted by the door. You will need this slide written down into your notes. Diffraction of radio waves. AM radio waves have longer wavelengths than FM radio waves do. Because of their longer wavelengths, AM radio waves diffract around obstacles like buildings and mountains. And as a result of that, we can usually get reception better on an AM radio than on an FM radio. Interference, writing this down, when two or more waves overlap and combine to form a new wave. The process is called interference. Interference occurs while two waves are overlapping. So as you can see in the picture here, as well as listed on page 292 of your textbook, you have a wave moving this way from this hand and a wave moving this way from this hand. And at some point it reaches up and then it comes back.
Two or more waves can combine to form a new wave. If the waves move in opposite directions, they can cancel or form a new wave of lesser or greater amplitude. The result of the superimposition of two or more waves is called interference. Wave interference can be either constructive or destructive. When two pulses with equal and opposite amplitude meet, the displacement of the medium at each point in the overlap region is reduced. The superimposition of waves with equal and opposite amplitudes causes destructive interference. When the pulses meet and are at the same location, the displacement is zero. Point N, which does not move at all, is called a node. The pulse continues to move and eventually resumes its original form. Constructive interference occurs when wave displacement is in the same direction. The result is a wave that has amplitude greater than those of any of the individual waves. The large pulse appears at point A when two waves meet. Point A has the larger displacement and is called the antinode. The two pulses pass each other without changing their shapes or sizes. If the pulses have unequal amplitude, the resultant pulse at the overlap is the algebraic sum of the two pulses.
So as the video showed you, and on page 293, please write down constructive interference. That means with constructive interference, the waves add together. This happens when the crests of the two or more transverse waves arrive at the same place, time, and overlap. And constructive interference, the amplitude of the new wave that forms is equal to the sum of the amplitude at the original wave. Destructive interference, the waves subtract from each other as they overlap. So a good way to think about that is destructive is a negative thing, and if it's negative, then I must subtract. And if constructive is a good thing, then it must be positive, therefore I'm adding. That's kind of how I can remember it. So you need to know for destructive interference, this happens when the crests of one of the transverse waves meet the troughs of the other transverse waves. Next bullet point, the amplitude of the new wave is the difference between the amplitudes of the waves that overlapped. Waves undergoing destructive interference are said to be out of phase. Standing wave is a special type of wave pattern that forms when waves equal in wavelength and amplitude, but traveling in opposite directions continuously interfere with each other. The places where the two waves always cancel are called the nodes. And this is something you should have written down, and is also on page 294. Have some really good graphic pictures on that page in your textbook. So there are something called standing waves in music. So when the strings of a violin is played with a bow, it vibrates and it produces standing waves. Some instruments, like flutes, produce standing waves in a column of air. And finally, resonance. This is the process by which an object is made to vibrate at its natural frequency. Therefore, if enough energy is transferred to the object can vibrate so strongly that it breaks apart.